Okay, this is 4.1 part 2, so I'm going to pick back up where I left off, which was talking about multiplicity and why it's important. Okay, so if a zero, this says if a zero has an even multiplicity, then the graph is going to touch the x-axis at r, which is that x-intercept. What does that mean? I'll explain in a second. If a zero has an odd multiplicity, then the graph is going to cross the x-axis at r. So I think about your parent even function, quadratic, versus your parent odd function, a cubic, something like that. Both of those are going to have an x-intercept of 0, right? They both have an x-intercept at 0. They touch the x-axis at 0. But this one with the even multiplicity, okay, this one just comes down and touches the x-axis. Whereas this one, with this next one, with the odd, are you seeing that? How blue is selected and it's not writing blue? Okay, there we go. This one with the odd power, it actually, you think about the parent function, you know these graphs, it crosses through the x-axis. And this is really going to help us graph later on in these notes. Okay, so then another important thing is turning points, where, okay, so if I draw this, just making up this polynomial here, this could be a polynomial. It's smooth and continuous. You'll notice it has 1, 2, 3, 4 turning points. Okay, so back up here, functions of degree, I have it generalized. Let's say it's 5. Okay, so if a function is 5th degree, that's a quintic, if you want to learn that, then it can have at most 4 turning points. Okay, that's not generalized, that's specific. I want to generalize. So if I say n, then you would say it has n minus 1 turning points. Okay, let's say you're not looking at the function, you're instead looking at the graph and you count 1, 2, 3, 4 turning points. That means that this degree, it can't be a 3rd degree. It has to at least be n. Okay, it has to at least be 1 more degree than the amount of turning points. Now, it could be 6th, 7th, 8th degree. Okay, but it at least has to be, like in this example here, a 5th degree polynomial. Okay, so an example here, there's actually 2 of them here and they didn't copy. The first one looks like this if you don't have the note sheet printed off. F of x equals 4 times x minus 4 to the 5th times x plus 2 to the 3rd times 2x minus 3 squared. And I'm going to kind of change the directions on here, and this is how I kind of want you to interpret your homework that's like this too, because it says identify the zeros. The way I'm going to do that is I'm going to identify the zeros by putting them, let's see, by putting them directly on the x-axis. So if x minus 4 is a factor, that means x equals positive 4 is an intercept. Okay, it's a good time to talk about this just being a 4. That doesn't give you an x-intercept. That's just a leading coefficient, okay? If x plus 2 is a factor, that means that x equals negative 2 is an intercept. And then 2x minus 3. If you can't see this, we've practiced this, I think in, I don't know, way back to conics, that would be plus 3. So x equals 3 halves. It's 1.5. Okay, those are your intercepts. So then I want to be able to draw this, but we actually got to skip ahead in the notes once before we do this. But one other thing it says state the max number of turning points. Okay, so the thing about that is we have to know this factored form is great for seeing the zeros. What it's not great for is knowing the total degree of this polynomial. So to get the degree of the actual polynomial, you are going to just add up the powers. So the degree is going to be not this one. It has to be powers on x's. This is not an x. So it would be x to the 5th plus x to the 3rd, plus this would technically be 4x squared. So that would be 5 plus 3 plus 2. So this is a 10th degree polynomial. So that means it has at most 9 turning points. I don't think it does, but that would be the max it could have. Okay, I want to finish graphing this, but actually first we've got to jump ahead and we've got to talk about the end behavior theorem before we can actually finish graphing that. Okay, so for end behavior, you need to look at the leading term in standard form, which means not factored form, which is kind of a bummer because a lot of these are probably going to be in factored form and you don't necessarily have to go all the way, multiply everything all out, but you've got to have an idea of what that leading term is. Okay, so I need you to divide this little space that you have on your note sheet into 4 areas, okay? Because what you could have, that leading term could be a positive number times x raised to an even power. Okay, it could also be a negative number in front of x raised to an even power. And then we basically have to do the same thing except for odd. It could be a positive number in front of x raised to an odd power. Or it could be a negative number in front of x raised to an odd power. Okay, that is going to determine what the end behavior looks like. If you have a positive number in front of x raised to an even power, 2, 4, 6, 8, you are going to have end behavior like your regular quadratic, okay? Going upwards, right? So what I do is I draw this little circle because the amount of turning points that are happening in the middle, that isn't determined by the leading coefficient, but it's going to end on each side like that, just like x squared does and 5x squared does. Now, what if it's instead negative 5x squared? Again, we'll talk more about what's happening in the middle later, but it ends going down. Okay, this one is like the x cubed we talked about earlier. If it's positive x cubed, again, we could have lots of different things going on in the middle, especially when you start talking about things like 25x to the 27th, okay, an odd power. But as long as it's positive, the right side goes up and the left side goes down. But the moment it's negative 3 times x to the 27th, then that just flips and the left side goes up and the right side goes down. Okay, those are your options for end behavior. That is going to help us finish this problem because If we can get the end behavior, we can then fill in the middle. Okay, but first, we've got to know if the leading coefficient would be positive or negative. So I do not want to have to do all the multiplication here. That would be crazy. But the thing is if I were to multiply x minus 4 out times itself 5 times, it would be x to the 5th plus dot, dot, dot. Okay, that's a 5. And then this one would be x cubed plus dot, dot, dot. And this one, that one's a little easier to see. Right away, if you were to FOIL 2x minus 3 times 2x minus 3, you would have 4x squared. Okay, so then if I multiplied all these together, I'd have this 4 times this times this times this. That would be your leading coefficient, which would be 16 x to the 10th. Okay, so this is positive and this is even. So that means we have this first one here. So the end behavior I'm going to fill in first. It ends like this. Okay, so then I need to go to each of these zeros. At -2, I have an odd multiplicity, which means I need to cross through -2. So I'm going to come down and cross through -2. Okay, so then I got to move over to 3/2, which is 1.5. That one has an even multiplicity, so I just need to go up and touch 3/2. Okay, so now this is where it gets a little bit ambiguous or just subjective. I don't know exactly when I turn around. So like this moment right here where I'm turning around and heading to this 0 just to touch it, not cross through it. This is where there's a little bit of ambiguity, and I'm not going to grade you on where exactly you turn around right now. Okay, but then the last one, I'm betting I have to cross through it because I've got to get up to this end behavior. And sure enough, at +4, I have a power of 5. And, okay, so just to make sure you know where I'm getting this is from earlier on if you turn over to the front page of your notes, right at the bottom. If I have an odd power, I am going to cross through the x-axis, like so. Alrighty, let's do another one. The next one is f of x equals x to the 4th times x minus 2. And this is how I want you to practice your homework that's like this. Even if the book doesn't say, if it just says to list them, I want you to practice graphing them. Okay, so that means that I have an x-intercept at 0. This one gives me the x-intercept 0. This one gives me +2. And this one gives me -1. Now, if I were to multiply this all out, I don't want to have to do that, but it would be x to the 4th, and this is raised to the 1st. So it would be x to the 4th times x squared, which would be x to the 7th. And it would just have a 1 in front of it, right? So I've got +1 times x to the 7th, which means my end behavior is this one. Okay? So then starting, I'm going to just go left to right. So starting with -1, that has an even multiplicity. So I'm going to touch at -1. So as I head to -1 from here, I'm just touching it. So that means I'm turning back around. 0 is the next one. That's raised to the 4th. So that also just means touch. Now, the question is I can't go down too far before I head back up there. Okay, but I'm just going to, again, touch. And then +2 is raised to the 1st. That's a multiplicity of 1. 1 is odd, so that means I'm going to cross, which makes sense. I have to cross to get back through so that I can get up to that end behavior. So touch, touch, cross, and that's all based on the multiplicity. Since it's raised to the 7th, I would have at most 6 turning points. But you can see, I mean, that's the maximum. I only have 1, 2, 3, it looks like. Okay, we are almost done here. Just a note, this is on the note sheet completely filled in, but when analyzing the graph of a polynomial function without a calculator, I want you to know the degree, the max number of turning points, the end behavior, the x and y intercepts, zeros and their multiplicities, and if the graph crosses or touches at each. We didn't really do the y-intercept. I should have done that. I wasn't really thinking, but here the y-intercept is also just 0 since it has a 0 at x. Now this one, the y-intercept would be if x is 0. So it would be if x is 0, that would be 4 times 0 minus 4 to the 5th times 2 to the 3rd. And then this one would become 0, so it would be negative 3 squared. And that would all be multiplied. Okay, so if you plug that into your calculator, I'm doing that now. Oops. 2 to the 5th times 2 to the 3rd times negative 3 squared. Okay, I get like a really, really negative number, which shows me that this turning point right here is not accurate because my y-intercept is like negative 294,912. So that means that in reality, this dips a lot lower than I actually have drawn. Okay, last example, analyze the graph of this polynomial. So we're going to basically just do again what we've been doing. The polynomial is f of x equals 2x minus 1 times x plus 2 squared. So in factored form, it's very easy to go ahead and say I have an x-intercept of negative 2 and I have an x-intercept of 1/2. Also, I would have a y-intercept of, it would be, if x is 0, so negative 1 times 2 squared, which would be negative 4. Okay, let's talk about end behavior. That would be, we got to look at the leading coefficient. So if I were, this one wouldn't be that hard to multiply out completely, but when you FOIL this, that would be x squared plus 2x plus 4x plus 4. So you would take x squared times 2x to get 2x cubed. So if this was completely multiplied out, the leading term would be 2x cubed. And then obviously there would be other terms, but this one would be the first one, which means that the end behavior is this one for a positive odd end behavior. Okay. Starting from the left, going up to negative 2. Negative 2 has an even power, so I am going to touch the x-axis only at negative 2. So I'm going to head up and just touch, which means I turn back around. Okay, so then I do have to come and go through this y-intercept. Okay, and then the question is, am I going to touch or am I going to cross? Well, hopefully I cross so that I can head up to that end behavior. And sure enough, this is raised to the first, which is odd. So I am just going to touch and pass through. Okay, so your homework is kind of long. I'll have some Zoom sessions to go over questions, but you can also email me.